Hi, welcome to another video on hypothesis testing. I'll talk in this video about tail test. It's also known as left tail test. So far we have seen the two-sided tests. We'll see one-sided test in this video. So lower tail test of a population with known variance. So we know the variance of it. It's known. And we like to compare the population mean of one population with some sort of a limit. Well, the limit here is the mean of another population, and we want to know whether mean of population 1 is greater than equal to mean of population 2. Now here it's not equal to, it is like one-sided, like we like to know whether it's greater or not. Also in one-sided we could also see whether mean of 1 is less than mean of 2 or not. So these are basically one-sided examples. When you take equal to, that's actually both sides. Okay, mean 2 is, by the way, is just a limit here, so we do not have to know the variance of it, and that's the null hypothesis, that mean 1 is greater than equal to mean 2. So null hypothesis, the alternative hypothesis is that the null hypothesis is not true, right? So it's as simple as that. So for this, we'll calculate the test statistic ourselves. It's pretty simple. Mean 1 minus mean 2 divided by standard deviation of mean 1. Remember here, the population given to us is mean 1. Mean 2 is just a number, right? And it's just a number from another population, right? I do not have to calculate the standard deviation or the variance of it. So that's not needed. That's just a limit we are comparing to. Okay, so using this formula, we can calculate. It's a standard formula in the calculation of the J statistic. Mean 1 minus mean 2 divided by the standard error, which can be calculated as standard deviation divided by square root of number of observations, right? So that's a pretty standard formula used. And how we will assess the test outcome. Well, first you calculate Z. Well, Z is basically the test statistic, right? It's popular, it's also commonly known as Z. It's less than the threshold. At 95% confidence level, the thresholds are negative 1.65 and positive 1.65. So for the, if it is, in this case, obviously it is negative side. So if it is less than this threshold, like negative 1.65, or it's falling outside of these thresholds, right? If you actually see the distribution and see the tails, right? I'm sure you have gone through and you have seen those things. To see the tail, if something falls outside of this threshold, then we actually reject the null hypothesis then, right? Which is, in other words, actually we can say that p value is less than 0.05, right? That's easier normally to interpret from p value, and we have seen that in other videos, right, where we just calculate p value, and from there we interpret and understand the test outcome. All right, so some hypothetical numbers I've taken. Mean 1 is 9,900, mean 2 is 10,000. Sigma is basically your standard deviation, okay, and n is total number of observations. So our null hypothesis is that mean 1 is greater than equal to mean 2. In other words, 9,900 is greater than equal to 10,000. We calculate the test statistics, right? The Z value, and the formula that I just discussed is something I've used. So mean 1 minus mean 2 divided by sigma divided by square root of n, right? That's the way you can calculate the Z value, and then compare it with the theoretical t distribution, and then see actually if it is falling outside the thresholds or not. Or to make it simpler, just see whether the value is less than a negative 1.65. That's at 95% level. If you want to change the confidence bound, well, the popular one is 95% confidence level, but you can also make it 99% or 90% also. Sometimes people use other confidence levels. All right, so let us run this. Now here you see the Z value is negative 4.56, which is less than negative 1.65, right? Hence we reject the null hypothesis, right? So here, if actually, if you actually use some function, it will obviously give some. If you use some built-in function, obviously you will get the p-values, and in this case, you will get a p-value of less than 0.05. All right. So, but since we are calculating ourselves, we don't have it, right? We don't have the p-value, but you can certainly calculate it also yourself. Not a problem. But even from the z value itself, you can compare and conclude, right? But good to have the theoretical distribution in front of you just to verify that. But since we have taken 95% confidence level, and we all know that it is negative 1.65 in this case, it's a no-brainer then just to comparing two numbers then, right? And you can get to know whether to accept the null hypothesis and or reject, right? All right, so see you in another tutorial.